Alright guys and gals, this video is an introduction to trigonometric ratios, or Trig for short. If you've got the notes to follow along with, make sure you do so. We'll go through this relatively quickly. If you've got questions, make sure you see me at some point. Alright, so let's talk about trigonometry. Trigonometry literally means, well, let's look. We can break it down to two parts. We've got trigon, okay, meaning triangle, and metron, meaning to measure. So literally we're talking about the measure of triangles. Now, when we're talking about trig in particular, what we're really wanting to talk about is the study of right triangles. At least that's what we're going to use it for the time being. All right. And what trig is it's a set of ratios comparing sides of a right triangle to each other and looking at the angle that's expressed by those sides. So for example, if we've got triangle ABC, then we can look at side AC and side AB as it relates to this 35-degree angle. There's a relationship between the lengths of these sides and the angle measure that we have here. And we know that's going to be true in all cases because it's a right triangle. So let's talk about that idea a little bit more. Take a look at these two right triangles. We know they share this 90-degree angle in common. We also know that they happen to share this 35-degree angle in common. But notice they're not the same size. Okay? But here's the deal. By angle-angle similarity, we know that these two will have to be similar. So the relationship, for example, between side HF and HG is going to be proportional to our side JL and LK, regardless of size. So these ratios are going to hold and be proportional. So if I'm dealing with, say, a 35-degree angle, and let's say JL is 8, and again another 35-degree angle, and let's say this side is 3, the ratios that are formed here are going to be proportional. So trig can be used for any right triangle, and you're always going to get good results. It's not going to be necessarily a new formula or a new method every single time. All right? So let's talk a little bit more about the ratios and what sort of ratios we can develop. All right? We have 3 at this point that we'll study. If you look on a calculator, let me grab one here, you'll see the trig functions on your TI-8483 kind of in the middle of the keypad, SIN, COS, and TAN. What those represent are the names of the ratios. The first one is called sine. It is not sin. This is not church. We're not talking theology. Sine. All right? And the sine ratio is measured as the opposite side of a triangle over the hypotenuse relative to angle A. So let's look at this triangle here real quick. This is angle A. So if I'm talking about the opposite side, okay, here's angle A. Its opposite side in this case would be CB, okay, or we'll call it side A. The hypotenuse is going to be the hypotenuse regardless of the angle we're talking about. So in this case, segment AB, or we'll just call it side C for short. Notice the way these sides and angles are measured. If this is angle A, then side A is opposite it. If this is side C, then it's opposite angle C, and so on. If we want to look at sine of angle B, all right, we can do that as well. Again, opposite, so B, over hypotenuse, C. So both angles A and B can have a sine ratio. Notice that at no point are we ever going to use our trig functions, these ratios, for the right angle. Okay, that doesn't play ball. Right? So no joy there. So the only time we're going to use these ratios are for the other two angles that are not 90 degrees. All right? So again, sine is opposite over hypotenuse. That's the ratio that's formed, depending on the angle that you're looking at it from. All right? The other one is not cos, it's cosine. Okay? And the way cosine is done is its adjacent side over hypotenuse. So let's look at that. So here's angle A again. So if I wanted to know its cosine ratio, what we would do is look at its adjacent side. So adjacent meaning right next door. So the adjacent side in this case is side B, okay, AC if we wanted to name it by the points. So side B over hypotenuse, again, side AB or C. All right, in this case, we'll name it as C. So adjacent over hypotenuse. If we wanted to find the cosine of angle B, then again, adjacent, so side A in this case, over hypotenuse, side C. So again, the cosine ratio is made up of the adjacent side and the hypotenuse. Now remember, adjacent meaning immediately beside. So in this case, adjacent meaning A, not C. C is always the hypotenuse. Hypotenuse is the hypotenuse is the hypotenuse. All right? Adjacent meaning the other side that's right next to the angle, and then opposite meaning, well, the one that is opposite from it. The last one, on your calculator, it's labeled TAN. That is short for tangent. Okay? Tangent of, or our tangent ratio here, if we're looking at, say, the tangent of angle A, is the opposite sides, in this case A, over the adjacent side. All right, so A over B. If we're looking at the tangent of B, so here's angle B, its ratio would be the opposite side, so angle B, over adjacent angle A. So again, tangent ratio is made up of the opposite side over the adjacent side. So notice something here real quick. Both sine and cosine deal in hypotenuse. Okay? Tangent does not. Okay? Tangent is our only trig ratio at this point that does not deal in the hypotenuse. It deals with the opposite side over the adjacent side. Okay? If you look at sine, while it deals with the hypotenuse, it only deals in the opposite side. And if you look at cosine, while it does deal in hypotenuse, it only deals with the adjacent side. So a lot of students say, well, how in the world am I ever going to remember these three ratios? They kind of sound alike in some cases, sine or cosine. They start to look alike. They're only dealing with these three sides. How in the world am I ever going to get these straight? Well, that's a great question. This is how you're going to do it. We can keep our ratios straight, okay, and figure out what they are by this mnemonic device. It's pronounced so, ka, toa. Now, some teachers will tell you a sappy story about Native Americans and some Indian chief and how this is a special word, blah, blah, blah. We're not doing that here. Look, it's just a quick and easy way for you to remember how to do it. So, and I'm going to write these kind of small. Ka, toa. Okay? The first letter represents your trig function or your trig ratio. Okay? Notice I'll use those terms interchangeably. The next two letters, represent the sides of the triangle that they use. So the sine of an angle uses opposite over hypotenuse. All right? The cosine of an angle will be represented as the adjacent side over the hypotenuse. All right? And the tangent of an angle represents the opposite over the adjacent. All right? So it's just a quick and easy way, and here's another way that it's written out, just a quick and easy way for you to remember your ratios. Now, a lot of students I know on the top of their homework as we're doing our right triangle work, or when it comes to quiz or test day, will actually write so, ka, toa at the top of the paper so that way they can remember their ratios. And if that helps you, by all means, do it. If you don't need it, if you can memorize these functions without it, then don't do it. But a lot of folks like this. It's a very quick and easy mnemonic device to remember. So, ka, toa. Quick and easy way to remember. All right, so let's actually start using these things. So just to get kind of introduced and make things kind of simple, here's a right triangle. Okay? And what we're asked to do here is to express each ratio both as a fraction and as a decimal to the nearest hundredths position. Okay? So let's take a look. Notice in this case, we don't know what any of the angle measures are, and quite frankly, we don't need to. All we're looking at today is just to get the practice of can we figure out what the ratio is. All right? So notice we're finding sines and cosines and tangents. So again, if you don't remember, well, for example, sine of P. So here's angle P. Well, which of these three sides do we use? Use your acronym, and I'll write it up here for you. So, ka, toa. And again, if that helps you to remember your ratios, then by all means, use it. So let's find the sine of angle P and see what that ratio looks like. So again, sine is opposite. So here's angle P. The opposite side is 15. So let's write that down. 15 over the hypotenuse. So in this case, our hypotenuse is here. Remember, it's opposite that right angle. It's 17. So on a calculator real quick, you can type in 15 over 17. We were asked to round to the nearest hundredths position. So it is approximately 0. Let's see what we get here, 88 hundredths. All right, once we round. All right. Let's find the cosine of angle P. So cosine, we said, is adjacent, so 8, over the hypotenuse. So hypotenuse is always hypotenuse, so 17. All right. Which is approximately, if we take 8 over 17, let's see, that gets us approximately 47 hundredths. All right, good. Let's try the tangent of P. Remember, tangent's the only ratio that we'll be using that doesn't involve the hypotenuse. So in this case, the opposite side, so 15, over the adjacent side, so 8. And that is approximately, so let's see, 15 over 8, should be, let's see, again, we're rounding to the hundredths position. So that is approximately 1.88. Now, a note on our ratios here. Notice how some of our ratios are coming out as proper fractions. You know, the numerator is smaller than the denominator, and that's fine. Sometimes you'll get ratios that aren't. Leave them like this. We do not write our ratios as mixed numbers. Okay, so if you get something, for example, like tangent of p is 15 over 8, leave it as 15 over 8. Do not try to rewrite that as a mixed number. All right, leave them improper. It's expected in this case. All right, let's change sides around, or excuse me, angles for that matter. So the sine of q. So notice our perspective is changing since we're talking about angle q. So if I'm looking at sine, so again, opposite over hypotenuse, from angle q's perspective, the opposite side is 8. So let's write that down. So 8. We need the hypotenuse. Hypotenuse doesn't change. It's always the hypotenuse, so 17. And I want you to notice something. 8 over 17, well, we just found that. So there's no need in typing that into our calculator again. We'll just reach up here and borrow. But notice how that happened. The cosine of one angle happens to be the sine of the other. That's kind of an interesting relationship, don't you think? Let's try something else. Let's do the cosine of q. So let's see. Q, we need the adjacent side here, so that's 15 in its case. So let's write it down. 15. And then we need the hypotenuse, so that's always going to be the same, so 17. And let's see now. Well, that looks familiar too. The sine of one angle happens to be the cosine of the other. Huh, go figure. I wonder why that is. Maybe you'll figure it out. Let's try this last one. Tangent of q. So, q, we need the opposite side. So opposite is 8 over the adjacent side. So in this case, 15. Doesn't look like we've worked that one out yet, so we can't borrow. We're going to have to actually work it out. So 8 over 15 gives us roughly 53 hundredths once we round. Notice the tangent of one appears to be the reciprocal of the other. That's something to keep in mind. All right? So again, that's just how we'll create our ratios. Again, this is just practice on how to do it. And again, if you don't remember whether you need opposite or you need adjacent or hypotenuse, SOHCAHTOA can help you figure out what your ratios should look like. All right, let's move on. We'll try it again. Express each ratio as a fraction as a decimal to the nearest hundredth. So again, if you're having a hard time, remember, well, what is sine, what is cosine, whatever. Again, write your acronym, or excuse me, your mnemonic device rather. So, ka, toa. Okay? Now, if you want to take a moment and try and work these problems out on your own, if you've got the notes to follow along, then go ahead and pause the video, do that, and then come back when you're finished and get the answers. But I'm going to go ahead and start working them out. So we need the sine of angle A. So let's do that. So the sine of angle A is, well, let's look. Here's angle A. I need opposite, so 16, over hypotenuse. So again, I'm going to, for some people, they like to draw an arrow from the right angle there to the hypotenuse, just to remind them that that is the hypotenuse at all times. And if you want to do that, go right ahead. So over 20. If you can simplify it, go ahead and do so. So in this case, I can divide both of these numbers by 4. So that's 4 over 5. Okay, and then we can get our decimal here. 4 over 5 is just another way to talk about decimal 8 or 8/10. No need to round to the hundredths position in this case. Excuse me. So let's move on. Tangent of C. So here's C. Tangent is opposite. So in this case, 12 over the adjacent side of 16. Again, I can simplify that. Divide both of those by 4. So 3 over 4. And in this case, there is no real need to type it into a calculator and round. 3 over 4 is just simply 75 hundredths. So that's making things kind of easy. All right, let's look at the cosine of A. So we're going to switch our perspective again. Here's A. Cosine is adjacent, so in this case 12, over the hypotenuse of 20. All right, so we could rewrite that. 12 over 20, we can divide both those numbers by, let's see, 4. So 3 over 5, which equals 6/10. No need in writing it to the hundredths position in this case. All right, let's go back. Now remember what we saw in our last examples. We said that tangents appeared to be the reciprocals of each other. Well, if that's the case, then we would expect the tangent of A to be 16 over 12. Let's see if we're right. So tangent is opposite, so let's look at A. Opposite is 16, sure enough, over adjacent, which is 12. Sure enough, that pattern still held. So tangents are reciprocals of each other from one angle to the other. So in this case, we can rewrite this as 4 over 3, which we can then rewrite as 1, because again, 3 goes into 4 once. And then you would have 1/3 left over, so we can just simply write it as 1.33 or 1 33/100. All right? Let's try our cosine. Now remember what we talked about the last time. We said that cosine of one angle appeared to be the sine of the other. Well, let's test it and see. So in this case, cosine of C should look an awful lot like sine of A. Well, let's try it. So cosine is adjacent. So let's look. Here's angle C. Adjacent is 16. So it seems to match so far. Over hypotenuse, which is 20. Sure enough, it's exactly the same. So 4 over 5, or simply 8/10. All right. So let's get going here and see what we've got. C, sine of C. Well, we would expect the sine of C and the cosine of A to also be the same. So let's try it and see what happens. See, here is C. So the sine of C is opposite sides, in this case 12, over the hypotenuse of 20. Sure enough, they're exactly the same. So 3 over 5 when we simplify, or 6/10 when we write it out as a decimal. All right, so good. Now, let's take a look at question 7. It's a little bit different. It says, use a special right triangle to express the sine of 60 as a fraction and as a decimal to the nearest hundredth. All right, well, notice it didn't give us a triangle, so let's draw one real quick. So here's just a nondescript 30, 60, 90 right triangle. Okay? Now, notice they didn't give us any side measures to use, so let's make them up on our own. For example, let's let the shortest side go ahead and be 1 unit long. Might as well make it easy on ourselves. Well, we know our relationship here in a special right triangle. If this is 1, then the hypotenuse is twice that amount. So we'll make it 2. And we said this other side, okay, this third side, is going to be the shorter side multiplied by the square root of 3. So 1 multiplied by square root of 3 is simply square root 3. So there's no sense in making this more complicated than it needs to be. All right? Well, notice it said it wants to know the sine of the 60-degree angle. Well, here's the 60-degree angle, so let's write that out. So sine of 60 degrees is equivalent to what? All right, well, remember, sine is opposite, so let's look at our opposite side here. So 60 degrees, opposite side is square root 3, so let's write that down. The square root of 3 over the hypotenuse. All right, well, the hypotenuse in this case is 2. So that would be the sine of 60 degrees, the square root of 3 over 2. Now, notice it did ask us to go ahead and write it as a decimal to the nearest hundredths position. So let's approximate that. So if I take the square root of 3, now a point of order, real quick. If you're using one of these calculators and you type in square root 3, you cannot immediately type divide by 2. All right, because if you do, watch what happens. Okay, that's the answer you get. Hold on to that thought. If I take square root 3, put it in parentheses like you should, and then hit divide by 2, notice the difference in your answer. There's quite a difference there. So make sure you are putting parentheses around your value inside the radical here, in this case 3, to get yourself a good answer. Otherwise, you're going to get this garbage, and, well, hey, you're going to be off. So let's write it down. So the sine of 60 degrees is approximately, rounding to the hundredths position, 87 hundredths. All right? So again, that's the work that you're going to be doing today as we introduce trig. Now, one thing I would like to do is show you a different way than your calculator using these buttons to come up with these values. Okay? And notice, we said sine of 60 is this. Let's try it. Sine of 60 degrees, close parentheses so we don't do something silly. What do you know? Oh, hold on. Mode. Very good. This brings up a good point. Let me go back. Notice we got a different answer here. Sine of 60 is this negative nonsense, and what we thought the sine of 60 is this positive nonsense.